All right, guys, so what we're doing today and what we're starting today is chapter 5.4. We're starting chapter 5.4 today. And we're skipping 5.3 for the moment. We're going to go back to it because 5.3, 5.5, and 5.6 really go together. 5.4 is a little bit different. Now, the first thing we're going to be looking at in chapter 5.4 is isosceles triangle. A triangle has isosceles when it has at least two congruent sides. When it has exactly two congruent sides, those sides are going to be called the legs. So the congruent sides of an isosceles triangle are called the legs. Now the legs form an angle called the vertex angle. And that's that angle right there. So the angle that sides are the congruent sides is the vertex angle. Now the side that's not congruent to the other two is called the base. So the non-congruent side is called the base. The two congruent sides are called the legs. Interesting enough, they call the other two angles base angles. So the two angles that are touching are kind of part of the base are called the base angles. So an isosceles triangle has a vertex angle and two base angles, two congruent sides, which are called the legs, and then we also have the base. And these are kind of the parts, but it's not really, and it's helpful to know these because there's going to be some properties that come from these here. There's going to be some properties that come from these here. So, let's look at this here. Now, base angle theorem, or base angle theorem states if two sides of the triangle are congruent, then the angles opposite them are congruent. So since these two sides are congruent, it means these two angles here, B and C, are going to be congruent. The angles opposite the congruent sides are congruent. Now the converse of this theorem is also true. If I have two congruent angles, it means the sides opposite them are going to be congruent. So in an isosceles triangle, we will always have two congruent angles. If I have two congruent angles, it means the sides opposite them are congruent. If I have two congruent sides, their angles opposite them are congruent. So in an isosceles triangle, the base angles are always congruent every single time. Any questions on this here? Any questions on this so far? Okay. In this triangle here, DEF, DE is congruent to DF. Name two congruent angles. I name two congruent angles here. So what would be our congruent angles for this triangle? Angle E would be congruent to angle F. Because the angles opposite congruent sides are congruent. The angles opposite the congruent sides are going to be congruent every single time. Questions on this here? In the figure, angle A is congruent to angle B. Name two congruent sides. So what could we say? What can we say about this here? AC would be congruent to BC, because again, our converse theorem stated if two angles are congruent inside of a triangle, the sides opposite them are congruent as well. They're going to be congruent as well. And that's it. Questions on this here? Any questions on any of this here so far? And again, when we write the angles are congruent or the lines, we need to make sure we have the correct notation. So for line segments, we need a line segment above the letters. And for the angles, we need our angle marker. If HG is congruent to HK, then what? What angle is congruent to what angle? So what's one of the angles that would be congruent? So HG, need to be on the right, is congruent to HK. So what are the angles opposite them? Well, one of them would be angle G, yes? What would the other angle be? Well, I can't necessarily say K because there's one angle here and one angle here, yes? More than one angle, so I can't use a letter, but I need 3 letters then, yes? GKH. Or we can say HKG. GKH or HKG. And again, when we use the 3 letters, we're really just tracing that angle, starting on one of the sides, going to the vertex, and then to the other side. And because there's more than one angle there, we needed to use 3 letters. And again, since the angles opposite the congruent sides are congruent every single time. Any questions on this here? If angle KHJ is congruent to KJH, then what? So let's see what angles we're talking about. So starting at K, it's going to H, and then going to J. So we're talking about that angle there. Then we're also talking about going from K, going to J, going to H. So we're talking about this angle here being congruent to this angle here. So most likely we're talking about 2 side lengths. We're talking about 2 sides being congruent. Now what would those sides be? So KH would be congruent to JK because those are the sides opposite those congruent angles. Those are the sides that are opposite those congruent angles. Any questions on this here? Any questions on anything we've covered so far? If a triangle is equilateral, then it's equiangular. If a triangle is equiangular, then it's equilateral. So this is kind of helpful because from here on out, if a triangle is equilateral, it has to be equiangular. If a triangle is equiangular, all the angles are the same, then it has to be equilateral. These go together always. So what this is telling us is not only that all the sides are congruent, but all the angles are. All the angles are going to be congruent to each other. And if all the angles are congruent to each other, it means all the sides are congruent to each other. One means the other. These two go together always. So let's look at this here. So this first one here, find the measure of angle P, Q, and R. Well, what do we know about this triangle? What do I know about the side lengths? They're all the same, so it means that it's equilateral. if a triangle is equilateral, it also means that it's equiangular, yes? Equilateral and equiangular will always go together. So it means the value of P is going to be the same as the value of R, is going to be the same as the value of Q. All these angles are going to be the same, because if a triangle is equilateral, it also means that it's equiangular. So all those angles are the same. But what do I know that they add up to be? 180. Well, x plus x plus x is this point here, we can divide both sides by so x is 60. So the measure of angle P is 60. The measure of angle Q is 60. And the measure of angle R is 60 degrees, because each one of these angles, the measure is the same. The measure for each one of these angles is going to be the same, the exact same value. Any questions on this here? Any questions on any of this here so far? Find the side length of ST. So what do we know about the angles? Because they gave us some information about the angles, didn't they? What are they saying about angle ST and U? They're what? They're congruent. So all the angles are congruent, which means it's equiangular. And if a triangle is equiangular, it means it's also what? Equilateral. So all the sides would be the... So what is the length of ST? So ST would equal 5. How about US? All the side lengths would be the same. Since it's equiangular, it's also equilateral. Questions on this here? Questions on anything we've done so far? We good with this here? Find the value of x. Well, what do I know about all the angles inside of a triangle that is equilateral? They're all the same, because a triangle that is equilateral is also equiangular. So all these angles would be 2x. So I can say what? 2x plus 2x plus 2x is equal to? Well, 2x plus 2x plus 2x, 2 plus 2 plus 2 is? Then we can? So the value of x for this here is 30. Any questions on this here so far? Okay, let's look at this here. Find the value of x and y in the diagram. Okay, so now we're going to have to use some of the properties that we know. So let's fill in what we know for these here. Well, this one triangle here has 3 congruent angles, yes? So it's equiangular, which means it's also what? Equilateral. So all the sides are the same, yes? So all these sides are the same. Okay. So that's looking at the one with all the angles are congruent. But the other triangle only has how many? 2. So the angles opposite the congruent sides are what? Congruent. So these two, because these angles are congruent, so these sides must also be congruent. So I filled that in. I filled in what I knew. Now I wouldn't put 2 markers For this other triangle here, NLM, I wouldn't put two marks for these two lines here to say that they're congruent, because since the one already had one, I only need one because that's saying that they're congruent. Now, if these two here, the two that I colored in green, had been different than the three I drew first, then I would put two. But since they're all the same, we only need one. Because those two side lengths are the same, so that y equals 4. What do I know about x plus 1? So x is equal to 3. We can subtract 1 from both sides, and we get x is equal to 3. Questions on this here? Any questions on any of this here so far? So really, what is everything we've been doing today revolving around? The base angles of an isosceles triangle are congruent. If the base angles are congruent, the sides opposite are congruent. If two sides of a triangle are congruent, its base angles are congruent also. Then we had that an equilateral triangle is also equiangular, and an equiangular triangle is also equilateral. I think we have this one here, or one more, I think we have one more after this. So let's look at this one here. Now I'm going to start off with this here. These three angles are congruent, yes? So it means the sides opposite them are congruent as well. All the sides are congruent, yes? Well, I really don't have anything with the other triangle telling me the angles are congruent or sides are congruent, yes? Okay, so let's deal with y first. We'll get to x in a minute. What do I know about 4y? It's equal to what? 28. To find the value of y, I would divide by 4, yes? So y is equal to? These are both 28, aren't they? So what do I know about this length over here? So wait a minute, those two sides are, so is that a equilateral triangle? No, it's not equilateral, but it is isosceles, yes? Because isosceles is what? Has two sides. And the opposite angles of two congruent sides are what? Congruent. So this means that this angle over here is also 2x. Can we solve this yet? Because I know that 2x plus I need that third angle, don't I? Just saying that those two angles are equal means nothing. What do I know about these three angles here? Besides that they're all the same. They add up to be 180, yes? So we'll call it z. Z, z, z. Well, z plus z equals, so that's 3z equals, so z is equal to, I'll fill that in. So each one of these angles is 60 degrees. Yes. These two here add up to be 180. So we could do 180 minus 60, which would give us 120. So that means this angle here is 120 degrees. Any questions on how we got to this here? Any questions on any of this here so far? So we found the fact that the three angles in our equiangular triangle are all 60 degrees. Yes? So they're all 60 degrees. Now I noticed the angle that we were missing, that we really needed to find the value of x, did make a straight line with it. Yes? So those two would add together to be 180. And we found that that other angle is 120. Now we can use that. Because 2x plus 120 will give me, what is 2x plus 2x? Plus 120 is equal to, what would we do next? We would subtract 120 from both sides, which tells me that 4x is equal to 60. Because 180 minus 120 would be 60. And last but not least, what would we do? Divide both sides by 4, which tells us x is equal to 15. So the value of y, finding it wasn't too bad. We could pretty much, it was given to us. But here we had to do a few more steps to find the value of x. We had to do a few more steps. Any questions on this here? Any questions on anything we've done for this here? We good with this here? Yes? Now, I'm going to erase all this here. Make a little bit more room. Say I didn't find 120. This angle here, is that an exterior angle to that other triangle? Yeah, it's on the outside, isn't it? What do we know about the exterior angle theorem? The exterior angle is equal to the sum of the opposite two interior angles. So I could have said what? 2x plus 2x is equal to, well, 2x plus 2x is, does this look kind of familiar? Tells us x is equal to 15. So here we could have used the exterior angle, or we could have found that interior angle and gone from there. Both ways will work. Any questions on this here? Any questions on anything we've done so far? Let's look at the last one. Let's look at this last problem, because I think this is it, isn't it? So let's look at this here and let's see what we know. Well, we have a right angle here. All these sides here are congruent, yes? So that means all the angles inside of here would be congruent, because all of those would be x, yes? Does anybody have a guess at what that value of x is going to be? It's going to be 60. Because those three angles are going to add together to be what? What is the only way I can cut 180 into three equal pieces? 60. So an equiangular triangle will always be 60. The overall measure will be of each angle. So x is 60. It has to be 60. Oh, got to put the eraser down. So this would be 60, this would be 60, and this angle here would be 60. I'm going to call this z and this z. Because those two angles would be congruent because they are part of a what? An isosceles triangle. Get a different color. This triangle here is isosceles, yes? So z and z would be congruent. Now z, I think is what you're saying, angle z. Because z plus 60 degrees is 90, isn't it? Do you have questions on this here? Can we see that there? So if I want to find that angle, I would need to solve this here by Subtracting 60 from both sides. Well, the 60 minus 60 would cancel, leaving me z is equal to 30. So that angle there is 30 degrees, and that angle there is. Okay, so how would I find y? Yes, because we're saying y plus 30 is equal to 180. Because again, any three angles inside of a triangle add together to be 180. Well, 30 and 30 is 60. Bless you. We would subtract 60 from both sides and get y is equal to 120. Questions on this here? Questions on this here? Now looking at this here, because this is the last problem that we're going to do. Now looking at this here and the rest of the problems that we've done today, did any of these here, did we really just jump at a whole lot of formulas and proofs and this is the answer? I mean, some of them we did. Some of them we could see these match up, yes? But a lot of what I did with this here is really looking at the theorems and the postulates and seeing what does it say and what does it mean. Starting out and seeing, okay, well, I see that this is equilateral. All the sides are congruent. Okay, so I know the angles are congruent. Since I know that, I found that information, I filled it in. Then we noticed that 60 and z, what I called z, they made a right angle. So they had together be 90. I filled that in. Then we talked about, okay, it's an isosceles triangle, so those angles are congruent. And I worked it from one step to the next using these theorems. Are y'all seeing this here? And that's really what makes these here not as bad as they could be. Because if I just went straight to trying to see if I can find the values of x without looking at the theorems and seeing how they match up and seeing how they line up, it makes it harder. You could get there eventually, but a lot of it is I just start what I'm given and work from there. And seeing what is matching, what is congruent, and filling the information in. So if you need to fill in what is congruent and mark it up and mark what's congruent and mark what angles are congruent, mark what sides are congruent, do that because that's going to help. Okay? Being able to do it just by looking at it, great. But your likelihood of making a mistake goes up, especially if you're not used to it. So fill it in, mark it up, would be my suggestion. But we're not going to worry about that.